In this example, we want to graph y equals 1/2 cosecant of 4x. Now, before we graph the cosecant, what we're going to do is we're going to apply the transformations that are given to us with a and omega to our sine function. So we're going to first graph y equals 1/2 sine of 4x. And then whatever from this graph, we're going to use this graph to graph the cosecant. So we know that the value of a is 1/2, right? So that's the amplitude of the sine function. We know that the period is 2 pi divided by 4, which is pi divided by 2. So that's going to be our period. There's no vertical shift. There's no reflection because a is positive. So when graphing the sine function, we're still going to take our period and divide it by 4 or multiply it into quarters, right? So pi over 2 times 1/4 is pi over 8. So that means that all of our key points are going to happen every pi over 8 units. So we start at 0 here. This is pi over 8. Sorry, pi over 8. This is 2 pi over 8, which is pi over 4. This is 3 pi over 8. And then 4 pi over 8, which is pi over 2. And then it has an amplitude of 1/2. So this is, we'll call this 1, and we'll call this -1. So our sine function starts at an x-intercept, goes up to its maximum, back to an x-intercept, down to its minimum, back to an x-intercept. So this is our sine function here. And we're going to use this sine function to graph our cosecant function. So again, if you remember, anywhere that there was an x-intercept on the sine function, it becomes a vertical asymptote for the cosecant because the reciprocal of 0 is going to be an undefined value. So we're going to get x-intercepts, or sorry, x-intercepts are going to turn into vertical asymptotes. And then the maximum values of our sine function become the minimum values of that portion of our graph. And then the concavity of the cosecant function is just opposite the concavity of that section of the sine. So this is concave down for the sine, so it's going to be concave up for the cosecant there. And then it's bounded in between our vertical asymptotes. And then this minimum value becomes the maximum value of this section, and it's concave down here like this. And that would be the graph of y equals 1/2 cosecant 4x.